cardiovascular system is responsible for transporting nutrients and removing gaseous waste from the body. This system is comprised of the heart and the circulatory system. The circulatory system serves to move blood to a site where it can be oxygenated and where waste can be disposed. Circulation then serves to bring newly oxygenated blood to the tissues of the body. As oxygen and other chemicals diffuse out of the blood cells and into the fluids surrounding the cells of the body's tissues, waste produced diffuse into the blood cells to be carried away. An artery is an elastic blood vessel that transports blood away from the heart. There are two main types of arteries: pulmonary arteries and systemic arteries. Pulmonary arteries carry blood from the heart to the lungs where the blood picks up oxygen. The oxygen-rich blood is then returned to the heart via the pulmonary veins. Systemic arteries deliver blood to the rest of the body. The aorta is the main systemic artery and the largest artery of the body. It originates from the heart and branches out into smaller arteries which supply blood to the head region, the heart itself, and the lower regions of the body. The smallest arteries are called arterioles, and they play a vital role in microcirculation. The artery wall consists of 3 layers: tunica externae, which is the strong outer covering of arteries and veins. It is composed of connective tissue as well as collagen and elastic fibers. These fibers allow the arteries and veins to stretch to prevent overexpansion due to the pressure that is exerted on the walls by blood flow. Tunica media is the middle layer of the walls of arteries and veins. It is composed of smooth muscle and elastic fibers. This layer is thicker in arteries than in veins. Tunica intima is the inner layer of arteries and veins. In arteries, this layer is composed of an elastic membrane lining and smooth endothelium that is covered by elastic tissues. The artery wall expands and contracts due to pressure exerted by blood as it is pumped by the heart through the arteries. Arterial expansion and contraction, or pulse, coincides with the heart as it beats. The heartbeat is generated by cardiac conduction to force blood out of the heart and to the rest of the body. Veins can be categorized into 4 main types: pulmonary, systemic, superficial, and deep. Pulmonary veins carry oxygenated blood from the lungs to the left atrium of the heart. Systemic veins return oxygen-depleted blood from the rest of the body to the right atrium of the heart. Superficial veins are located close to the surface of the skin and are not located near a corresponding artery. Deep veins are located deep within the muscle tissues and are typically located near a corresponding artery with the same name. Veins are composed of layers of thin tissue. The vein wall is composed of tunica externae, tunica media, and tunica intima, as described previously. Vein walls are thinner and more elastic than artery walls. This animation represents a deep vein. Contraction of the surrounding muscles when you move your legs or ankles help to squeeze the blood back up towards your heart. Veins also have valves that prevent the blood from flowing back towards your feet and to your heart instead. A capillary is an extremely small blood vessel located within the tissues of the body that transports blood from arteries to veins. Capillary walls are thin and are composed of endothelium. Oxygen, carbon dioxide, nutrients, and wastes are exchanged through the thin walls of the capillaries. Capillaries are where fluids, gases, nutrients, and wastes are exchanged between the blood and body tissues by diffusion. Capillary walls contain small pores that allow certain substances to pass into and out of the blood vessel. Fluid exchange is controlled by blood pressure within the capillary vessel and osmotic pressure of the blood within the vessel. As blood enters the capillary bed on the arterial end, the blood pressure in the capillary vessel is greater than the osmotic pressure of the blood in the vessel. The net result is that fluid moves from the vessel to the body tissue. At the middle of the capillary bed, blood pressure in the vessel equals the osmotic pressure of the blood in the vessel. The net result is that fluid passes equally between the capillary vessel and the body tissue. Gases, nutrients, and waste are also exchanged at this point. On the venule end of the capillary bed, blood pressure in the vessel is less than the osmotic pressure of the blood in the vessel. The net result is that fluid, carbon dioxide, and waste are drawn from the body tissues into the capillary vessel.